I'm Nilaksh Das, a PhD student at Georgia Tech. In this video, I will present the key summary of our work, Best of Both Worlds, Robust Accented Speech Recognition with Adversarial Transfer Learning. We all know that training deep neural networks for automatic speech recognition requires large amounts of transcribed speech. Hence, acquiring tons of annotated speech data becomes a bottleneck for training ASR models, especially for accented speech. So, for example, we may have a lot of annotated US accent data, but not as much annotated data for Indian and Australian accents. So while we have huge amounts of annotated data from certain locales, it is oftentimes the case in practice that we only have access to unannotated data from other locales as it is easier to collect. In this work, we focus on this setting to explore how much gain can be made without undertaking the expensive and tedious task of annotating accented speech from different locales. For this, we leverage transfer learning and combine it with adversarial training. Domain adversarial training is an adversarial training technique that has been proposed in the literature to alleviate this problem. Given an ASR model trained with CTC loss, the DAT technique breaks up the model into an encoder and decoder and injects a discriminator along with a gradient reversal layer. DAT aims to learn a domain-invariant intermediate embedding space. In other words, it adversarially trains the encoder to filter out any accent-specific signals. Typically in DAT, all three parts are jointly trained, where the annotated speech is used in training with the CTC loss, and the unannotated speech with the accent labels is used to train the cross-entropy loss. However, this paradigm breaks down in the context of transfer learning. In this scenario, we start with a trained encoder and a trained decoder, whereas the discriminator is untrained. This can lead to spurious gradings being transmitted by the discriminator that would lead to suboptimal adversarial training. Hence, our key idea in this work is to perform accent pre-training of the discriminator. In order to do this, we first drop the decoder and the gradient reversal layer. We then freeze the encoder and only train the discriminator using cross-entropy loss. Note here that we don't require any speech annotations in this step since there is no CTC loss. We only need the accent labels for the speech. Finally, we perform DAT jointly with the trained encoder and the decoder with the now pre-trained discriminator. We perform in-depth analysis and ablations with annotated US accent speech and unannotated speech from 6 different accents. The table here shows the weighted average word error rate for different approaches. We see that DAT combined with transfer learning indeed improves accented speech recognition, and our proposed accent pre-training approach shown in the last row further improves upon the simple DAT. For more technical details and results from our work, please read our manuscript for this paper. Thank you.